Hey, what's up guys? This is going to be a getting started video for the BLE board, Bluetooth Low Energy. And in case you're not familiar with this board, check out the video description. This is a really cool, super easy way to get up and running with Bluetooth Low Energy. But in this video, I'm going to focus on getting started with it. So this is for people who just got the board, fresh out of the box, haven't plugged it in yet or anything like that. So I'll walk you through getting the software installed, loading a test program into the module, and then we'll even handle getting a little simple app to blink an LED on the board. So very simple, easy to use. And I made a video a few weeks back on this same kind of thing, but in this video we're going to start from scratch, nothing installed, and get up and running with it. So this is the board, and you're also going to get a little cut sheet here that kind of shows off what the board, what each of the pins do on the board. Just a nice little cheat sheet. And I've seen this with other microcontrollers, so I kind of copied what they did, and it's very easy just to see all of the different functionality you have with each pin. So obviously, you know, you've got two pins up here for ground and power. You want to make sure that you watch this and you don't accidentally plug 5 volts into the board. It's a 3.3 volt board. It can handle 1.7 to 3.6 volts. So even with a lithium cell, you know, you don't want a fully charged lithium cell running at 4.2 volts. You don't want to accidentally plug that in without it being regulated first. Okay, so that's where you apply power. You could also apply power via the USB to serial converter if you want, which is used for programming. Just make sure that you have VCC disconnected so that you don't have two supplies fighting each other. We'll talk more about that later on. But yeah, this is nice. So you can see all of your digital pins here in gray. One thing to note though is that sometimes you're going to see some pins have this this slash. So you have P11/27. And what that means is that inside the part we are dual bonding that pin. So you have two pins connected to one pin on the part. So basically what this does for you is give you more functionality, more flexibility on that pin. So you can see that you know, P11 here, if you selected P11, you can use that as a digital pin, a low current digital pin. You got to watch out for that. You see 2 milliamps on all of these digital pins. The red pins can handle a 16 milliamp output. So yeah, in this case, you could select either P11 or P27 for your digital I/O, but you just got to watch that you only pick one at a time if you're going to use this pin. So, you know, like if you picked, if you were in your program to configure P11 and P27, and you wrote P11 low and P27 high, well, you just created a dead short inside the part. So watch out for that. Make sure you only configure one of those pins that's dual bonded. But this is nice, you know, because now you've got P27. You could use P27 as a PWM output. P11 you could use as an analog input. So, you know, that kind of gives you that flexibility to do a lot more with this in a smaller footprint. Okay, so you know, you've got your digital I/O, you've got PWM output, so this is like your analog write in the Arduino. We'll make some tutorials on that later on. You've got analog inputs, you've got a serial UART, you see TX and RX on the bottom edges over here on the board, and I'll just give you a sneak peek. I'm working on making like a host microcontroller board, so if you didn't want to run your application program on this board, you can run it on a host microcontroller so that this board just plugs right in and communicates with it serially over the UART. So a lot of cool stuff there, and it'll all be Arduino compatible and all that cool stuff. So we'll talk about that later on, but yeah, you've got a serial UART there, you got an I2C, and of course a SPI port. So that's nice. And then there's an LED on the board as well, and that's connected to P0. And that's actually what we're going to use to test the board out. You'll see that there's 2 buttons on the board as well. The reset button here is used for programming. So you just press the reset button, and then you hit program in the GUI on the PC or Mac, and load the program in. The recover button you really don't need for anything unless your program gets corrupted or anything goes wrong. This is to recover the boot loader on the part. So yeah, again, if something gets corrupted, or maybe you write your application program and it's so big that it overwrites the bootloader for some reason, this gives you a chance to recover that. And we'll talk about that later on. I'll make a dedicated video just for recovering the bootloader. Okay, so that's pretty much it. There's a solder jumper on the bottom side of the board near the reset pin, and that's for development purposes only. Eventually, I want to figure out a way to get the board to program automatically without having to press the reset button. So I've got that solder jumper on the bottom there for developments, but you don't need to worry about it at all. Okay, so yeah, you program the board with the USB to serial converter. I'm using mine for this. This is my USB to serial converter that I developed. It's got 2 jumpers on there, so we can power the board from this converter by placing the power jumper in the on position, and the voltage level jumper in the 3.3 volt position, and then you're good to go. This is the setup right here, and this is what we're going to use in this video. So that's all we need. And again, this is just a getting started video, and we're going to dive into all of these different little features and functionality and all that kind of stuff in later videos. But for now, let's just get you up and running. So by getting the software installed, I had a little bit of an internet connection issue there, but we're going to go and start at Google, and I've got links to all this, so you don't need to Google these things on your own. But we're just going to start completely here from scratch. And it's the Atmosphere by Aaron. Okay, this is the tool they use. It's all web-based. And of course, if you're not into web-based programming, you can download an offline SDK and program it that way, which is nice. That's really the beauty of this part. That, you know, it's really easy to use for beginners. But at the same time, for advanced users, you can download the Broadcom SDK and program it all from scratch directly. So that's pretty cool. And of course, I will be making videos on that as well. Okay, so here we go. We're in Atmosphere. And the first thing we need to do is create a new account. And I'm actually going to work through this because I want to create a new account just for these tutorials. So let's see. Let's just make up a quick username. Okay, so we're all signed up now. I clicked on the link in the email they sent, the confirmation email, and then it asks you to confirm your email address and pick a password. So I did that, and then of course, you know, I forgot the uppercase character and all that kind of stuff. So we're all set up now, so I'm going to put in my information here, log in. Okay, cool. We are in. So now that we're in, we can jump into the IDE and we can start writing apps and creating programs and all that kind of stuff. But before we do that, I should have done this before I did this. But before I did that, what I really needed to do was go over to support and go to downloads, because we need a way to load the program onto the module. So we need like a little baby app that runs locally on the machine to be able to intercept the web-based program that you create and program it to the board. So let's see, we're gonna run the 1.51 here. Alright, so we got that downloaded. Yep. Good with all this? Yeah, sure. Okay, so now we have the programmer, so we have to log in to this as well. Tutorial. Remember the password. We're going to log in. Okay, cool, we're in. Okay, so don't worry about any of this. This is all very easy to work with, and we're going to talk more about this in future videos and all that kind of stuff. But right now, just leave this running in the background, and let's launch the IDE. So now we're ready to actually program or actually create our first program here. So you can see here this is the web-based interface, and they give you all of these drag and drop functions here. So you can see we've got the application side of things, and these are things, you know, that are running on the app side, and then we have embedded blocks, and then things that are specific to the Bluetooth low energy communication. So, you know, you can do battery alerts, and you can scan for devices and get a connection status, push alerts, all that kind of stuff. So we're going to talk more about that later on, but for now we just want to create a very simple program. So we're going to drag a button in, and you can see over here, this is kind of cool. This is where you create your program, and then over here we're creating the app at the same time. Now this app is created and will work with Windows Phone, Android, and iOS devices. Okay, so this is all created in real time, and you can actually change, you know, your layout here. So I have a 5S, an iPhone 5S. So we're just going to add that in right there, and then drag our button in, and then give our button a new label, and we're just going to call it LED toggle, something like that. Okay, so there we go, and we can also rename the button over here as well so that it makes more sense. You know, the LED, no spaces, LED toggle, something like that. Okay, cool. So we've got the button, and let's go ahead and toggle a GPIO pin now. So we can just select GPIO toggle right here. Okay, and then you see when you hover over one of these blocks, it kind of lights up a little bit. So if you want to just grab the one side as soon as the cursor changes, and then you click in and hold until you line up with the edge of another block. Okay, there we go. So now this button controls this GPIO toggle. You see there's a lot of parameters off to the bottom left here that you can tweak. But for now, you know, this is just getting started. We're just going to load a simple program in. We'll talk about all that other stuff later on. Again, the LED pin is on P0. So we're just going to go ahead and select P0 there, and that's it. Okay, there's not a whole lot there. We can also change a few things here with this connection here. So, you know, we can, let's see, mouse pressed, clicked, released, on trigger. So there's some things in there that we can tweak. There's a lot of functionality and different things we can do, and this can get quite complex in here. So even though it feels very beginner-like, you can actually create very complex programs within this tool. The other thing that I really like is that if you go over to code view here, it shows you the raw code and it, you know, how this all works. So you see we've created a function here for GPIO toggle. And it's basically, you know, getting the status of that pin and switching it around. Oh, well, this here, of course, is setting the mode of the pin. So, and again, we're going to talk more about this, but this is how they set the mode of pins. So, you know, our pin is pin 0. So it's setting the mode for that pin to a push-pull, which is an output. Okay? And then right here, we're doing a write on that pin, the opposite of what it is. So a toggle, and then return. Okay, and then of course we're, you know, right now it's just the default setup for it. So it's setting up, you know, your GPIO and the default power settings, UART, I2C SPI, the buzzer, and we're not dealing with any of that stuff. So we could actually take a lot of that out, but for now we're gonna leave it alone. Okay, so that's our program, very simple. And then over here, what we can do is just save this, and we're going to call this GPIO toggle. Okay, saving that. Okay, we can also go in here, look at the settings, and do a couple things here. So we are using the internal oscillator. I don't have an external oscillator on the board. We can change the name that is advertised. You know, so within the app, you can change the name here. There's a couple other cool things like over-the-air updating, which we're going to talk about later on, of course. You can change the output power level. Okay, the default is 4 dB there. And then the interval time, and we're going to talk again more about that, but that is the time at which it runs the interval function. Oh, and there's a lot more here, and they're always updating this too, so we've got a few more updates here. So you can change the sample frequency for the analog input, the PWM clock source, the full UART configuration here, baud rate, all that kind of stuff, and then even the SPI mode and SPI speed. So that's kind of cool. That's a new feature. I just seeing this now for the first time, so that's cool. Okay, and then of course you can give your program a little description up here. I like the save on build. That's a good one to have checked. Okay, so I'm happy with those settings. So now let's go ahead and build the project. So you just go up to project build, then you can watch your status here, and it's building it in the cloud. Okay, cool. So we are good, no errors or anything, and it tells you, you know, how big your program is and all that kind of stuff. You can also download the embedded source. So this is the code that runs on the module. You can download that, pull it right into the offline SDK and program it directly. You can download the app source and then take that app and load it into xcode or Android or Windows. It takes a little bit more configuration and setup to get that going, and maybe we'll talk about that. And I think that's all I really want to talk about here. The other thing that's really cool here, I just want to mention, is that if you're writing code in here, and you're going to see this in future videos, but if you're writing code in here and like, how do I set up a GPIO pin? This is great. I love this. The Arduino has this. This is great. So you go in here, you click the little button here next to GPIO driver, and yeah, you hit yes because it's going to open a new tab for you. And now it opens the wiki page with the explanation for all of those functions. So, you know, I just love that because, you know, nobody memorizes all of this stuff. So, you know, it's nice to have that right here built in. So, you know, if you know you need to do a UART, you just click that and it automatically launches that. And of course, you know, I will have videos set up for this stuff as well. Okay, so that all looks good. So we've got the program. It's built. It's good. Now, if we go over to the programmer that we just downloaded and we have set up here, you just have to, what do I need to do? Refresh project list. Okay, so I had to go to File, Refresh Project List, and now we see GPIO toggle here. So that's cool. We're all set up. Let me find my USB cable. The next thing we're going to do is go back over to the hardware here, and we've got the board, and we just need to plug it in, double check our jumpers. Okay, we want to make sure that we've got 3.3 volts, and we are applying power here. You want to make sure that you're not accidentally plugged in, you know, one pin over one way or the other and blow up the board, so make sure all of that is good. And we're going to plug this in. Okay, and I'm going to run it on Windows. Okay. Now, this is an FTDI part. It's the FT230X. So you should have these drivers. They should be already installed. So if I go over here and refresh, I see COM3. Okay. But if you didn't have the drivers and it's just sitting over here installing drivers and it fails for whatever reason, you can always get the drivers, FTDI driver. Okay, and I'll just go here, FTDI drivers, and we're looking at the virtual comport drivers. Okay, and then just go ahead and download the drivers for your operating system. Okay, very straightforward, and there's a lot of help out there. This is a very common part, so if you just search for whatever issue you might be running into, I'm sure you'll find a solution. Okay, so back to the programmer here. It sees COM3 there. We're going to program it. So what we need to do is press the reset button on the left here. Okay. Just press it once. That's all you need to do. There's no timeout or delay. It's stuck in reset right now, waiting for a program. So you don't need to do any weird timing, like press the reset button, then within like a second, press the program button over here. No, it's good to go. So now we hit the program button, and you can see the LEDs on the USB to serial converter are flashing, so we know it's programming. And then over here, of course, we see a status, and we are programmed. So now let's get our smartphone out, and I'm going to do a little bit of this off camera. But if you go to the App Store, I'm going to just do that real quick. Okay, so you want to search for Anarin Atmosphere in the app, okay, and download this app. And I'm sure it's called the same thing in Android and Windows. And you want to download that app, okay? And then when you launch it for the first time, you want to enter in your username and password. Okay, so as soon as you log in, it's going to load the app that you just created. So whatever your current app is over here, it's going to launch that over here. So if you create a new app, all you have to do is go in and refresh. Okay, so I hit the gears there. Oh, I had that little off camera. Sorry about that. You just have to hit the gears over here and just hit the refresh button, okay? And it'll pull in whatever the current app is that you're working on, okay? So here it is. Here's our current app. There's not a whole lot here. So if you hit the gears again and you hit scan, it's going to find that board we just programmed, okay? There it is. It sees it. And we can click on it and connect. And it's connected. And now if we press the button, you can see the LED turns on. Okay, it's as simple as that. And you just saw all of the different things we can do here. So this is why it's great. And then, you know, it is breadboard friendly, standard headers here. So you can plug that into a breadboard and wire up a circuit to it. And, or even better yet, you can develop your own little daughter board for it, and that plugs into that. I'm working on some prototyping boards that make it even easier to add in your own circuitry, all that kind of stuff. So there you go. That is a complete getting started guide for the board. That is how to do a simple GPIO digital write to a pin. And again, if we keep hitting the button there, we can see we can kind of toggle that and flash it. And part of that function, if you looked at it, was a digital read. So now you know how to do digital reads as well. Okay, so I just want to mention a few little minor things here. Actually, they could be quite major, and trust me, if you run into these things, you could try to chase them down, and it could take you hours. So here's a couple gotchas, things that you just keep an eye out for. So, for example, if you ever, so you got your, here you go, you got your program up and running here, and everything's cool, right? Then you go to unplug your USB to serial converter, so it's powered down. When you go to plug this back in and reapply power, you go into your app here, and you go to scan, and it's nowhere to be found. It's like the program disappeared. Now, I remember when this first happened, I was thinking, geez, well, where's my app? You know, what happened to the code there? Did it, you know, was it not stored properly? Or, you know, does it live in RAM and you have to, you know, burn it over to non-volatile memory? I wasn't sure what was going on. But here's the thing. When you boot the board up with the USB to serial converter plugged in, it boots up into reset. So it stays into reset right now, like it's waiting for a program. Okay, so keep that in mind. Now, under normal circumstances, you're going to be powering the board from the power pins here. Not an issue. So as long as the USB serial converter is not there, it's going to boot up and run your program, no problem. Okay, so don't worry about that. So so all you have to do though, if you're going to boot up with the USB to serial converter, is go over and reprogram the app. No big deal there. But I do want to mention something really quickly here. Okay, so the other thing I need to mention is if you're using the Atmosphere Programmer 1.51 here, and you go to program the board and it gives you an error, it says that it cannot open the port. This is major, okay? I was just battling with this today because I normally use a Mac, so I haven't run into this issue. But on Windows, when I was reprogramming the board, I was having this error. And apparently this is a common known issue, and Anarin is working on it. So if you ever run into that issue, just go ahead and download version 1.20. It's a little different than 1.51. download that, log in the same way you do normally here, set your serial port there to COM3, and go ahead and I'm going to reset it just again here, and then go ahead and hit program. Now this one doesn't let you select from a list of programs that you have in the cloud, okay? So this is going to only program the let me go back to the app. This is only going to download the app that you're currently working on, okay? So just keep that in mind. It's a little bit more crude than the newest version, but you know, it's all we got if you're going to run into that issue. Okay, so we just programmed that, and now we can see it again. We can go ahead and connect, and we're up and running again, no problem. Okay, so keep that in mind. So that is a complete getting started tutorial. So that's everything you need to get up and running with this. Get a program on there, get some basic GPIO functionality going, and of course get app communication. So anyway, just wanted to make that video. Trust me, we're going to be making a lot more videos, but just wanted to get started here. So there you go. Thanks for watching. Have fun.